Hi, I'm Rishabh. Today I have an introduction to Terraform course within AWS. So we'll be using Terraform to deploy some infrastructure to AWS and learn some concepts within Terraform. So without wasting any time, let's get started. So as I said, today we'll be covering Terraform, which is infrastructure as code tool, and we'll be utilizing it to deploy infrastructure to AWS. And who am I? If you're new to the channel, I'm Rishabh Kumar. I work as a staff developer evangelist at Twilio, and I'm an AWS community builder. Also, I recently became a HashiCorp ambassador, and I produce cloud and DevOps content. Before we get started, there are some requirements. So you do need an AWS account. You also need Terraform to be installed on your machine. You also need AWS CLI configured and installed. And this one is optional, but you can also have a domain name. Before diving into the project, let's talk about what Terraform is. So Terraform is an infrastructure as code tool that lets you define both cloud and on-prem resources in human readable configuration files that you can version, reuse, and share. So Terraform creates and manages resources on cloud platforms and other services through their application programming interface, also known as APIs. Providers within Terraform enable it to work with virtually any platform or service with an accessible API. HashiCorp and the Terraform community have already written thousands of providers to manage many different types of resources and services. You can find all publicly available providers on the Terraform registry, including AWS, Azure, GCP, Kubernetes, Splunk, Datadog, and many more. So what typically happens is you write your infrastructure configuration files as code, and you also get a Terraform state file. And this in whole makes your Terraform project. Then in your terminal, you type Terraform plan, and it will output all the different resources that needs to be deployed within the certain cloud providers that you are using. You review those changes and then run Terraform apply. This provisions the infrastructure according to your configuration files and the state file, and we'll talk about what state file is in depth later, and deploys it to the providers that you have mentioned or are using. So as I said, there are 1,000+ providers, so you can see AWS, GCP, and Azure among the popular ones. Now, going over the project. So this is the project that we will be building today. So as you can see, we have a website, so it will be a static website. And this course is more of an introduction to Terraform. And hence, I wanted to keep the project simple and focus more on the concepts within Terraform. So you have your website. It's a static website that will be hosted on AWS. So we'll be using S3 bucket along with CloudFront, which is the content distribution network. And optionally, you can use Route 53 to have your custom domain. I won't be covering the custom domain part, but we'll have a static website working with S3 bucket and CloudFront. But that is the project in a nutshell. As mentioned in the requirements, you need to have Terraform installed. So you can do that by going to terraform.io, and then you can click on download Terraform and install the version depending on your operating system. Similarly, you'll go ahead and do that for AWS command line interface or CLI. So go ahead and install that and also configure it. So you'll have to create IAM account within your AWS account and use that with your CLI. So once you have both of these configured, we can start writing some Terraform now. So I have my Visual Studio Code editor here, and you can use any IDE of your choice. I recommend Visual Studio Code. Now we are ready to start our project. So I have an empty directory here called terraform-aws-static.website. What I'm going to do is create a file called main.tf. So .tf is the extension that Terraform uses. And the programming language that Terraform uses is called HCL, which is HashiCorp's own language, right? So the first thing that we need, as I mentioned, how Terraform interacts with different cloud providers is using providers itself. So Terraform has thousands of providers. So if I go and look for the AWS one, the yellow flag that you see right next to AWS means that it's an official provider. So this is the AWS official provider, and you can see this is how you use it. So I can copy over this because I don't need a VPC, right? So let's go back to our main.tf, paste it. So now what we have is we have configured the AWS provider. But instead of US East 1, I'll use CA Central 1, which is the closest region to me, and you can use appropriate region based on your location. So now that we have our provider configured, and now you can also kind of tell the syntax that Terraform is using here. It'll make more sense as we start creating resources. And a resource within cloud provider could be an S3 bucket, which is what we need. So let's start by creating an AWS S3 bucket. So we'll type in resource, and as you can see, I have the Terraform extension installed. That is why I get these auto completions. So I would highly recommend that you also install the HashiCorp Terraform extension. And you also get, syntax highlighting and other features. But let's create the AWS underscore S3 and underscore bucket. So as you can see, I'm creating a resource. That resource is an S3 bucket. And this name here is whatever your resource name within the Terraform file needs to be. So this won't be the name of S3 bucket in AWS, but in the Terraform configuration file. So we'll change this to website bucket. That looks good. And here is where you define the bucket name. Remember, S3 buckets need to have a globally unique name. But I'm going to introduce another concept within Terraform here, which is called variables. So instead of hard coding the bucket name, we'll use variable. And you can do that by var.bucket underscore name. So this bit here, the bucket underscore name, is what I'll call my variable. As you can see, we have an error here because Terraform cannot find any declarations of this variable, which we'll fix later. But for now, you can choose whatever you find appropriate as your variable name. I think bucket underscore name fits perfectly. And you can call that variable by typing in var. Again, remember, we haven't declared our variable yet. The next thing to do after we have created our S3 bucket is to upload our website content. And as you can see, I don't have any website content available in my directory. So I'm gonna copy a static website quickly here. Okay, so I just quickly copied website directory. As you can see, it has two files, error.html and index.html. The index.html is pretty basic landing page, and it includes my social links. I can quickly show you here. If I click on go live, I have a Visual Studio Code extension installed that lets me render HTML pages. So this is the website, pretty simple. And you can see it has my socials, right? And then similarly, the error.html is more basic. It says, oops, there is an error. So once I've got those files in here, the next step is to upload those into the S3 bucket. So for that, we'll create another resource. And this time, the file that we'll upload will end up being an object. So let's create an object resource. And the name will be, and this is within the Terraform file. So Terraform configuration knows this resource as index.html or index_html. Now, we still have to define some properties within this resource. So the first is the bucket, which bucket this object should live in. And now comes another concept. You can relate to previous resource by typing in AWS S3 underscore bucket dot whatever the name of that resource within the Terraform configuration file is. There we go. So this way, whatever the name of this bucket is used, it'll know that I have to use the same here. And .id is the right way to do it. I forgot .id because S3 bucket in itself, after it's created, would have more properties. We have to access the ID property here. Key is going to be the name of the file, which is index.html. Source is where you define where this file should be uploaded from, which in our case lives under website. So website and index.html. And then e tag is another property. So file md5 website index.html. And this comes in handy with our state file. And I'll tell you later why. But just include this, and we'll go over it later. But we also need to tell what type of content we have in this file, which is text HTML. There we go. And now you can see we don't have any errors here. Earlier, we were seeing errors when we just defined the resource itself, but we didn't define the properties. That was because all of these 5 properties are required, or at least 4 of them are required. And you can look into that in the documentation itself. It mentions, what all properties you need to mention or settings you need to mention. And similarly, we'll create this for our error.html. So I'm just going to copy and change this to error underscore HTML and change this to error HTML. Same here. And the last one. There we go. So we have our bucket, our 2 HTML files uploaded to that bucket. Now, if we look at the diagram again, so we already have this part figured out. Now we need a CloudFront distribution. So let's go ahead and create that. And again, it's as simple as typing in resource and AWS CloudFront distribution. And we'll name this CloudFront distribution within the Terraform configuration. So now within our CloudFront distribution, again, you can look at this in the documentation. So we kind of know what we have to provide in terms of all the different properties that are required. There we go. Here's the resource. So you create your bucket, right? And then here's the CloudFront distribution. So you have your origin and you have all these different settings that you need to mention, right? Again, you can scroll down and look at the top level arguments, right? So if you have any question about any of the settings that I've mentioned there, please, feel free to go and look at the provider documentation available from Terraform. Most probably it'll make sense. But within CloudFront distribution, one of the first things you have is an origin. So if you've worked with CloudFront, you might know this. But origin is basically, where this CloudFront distribution is going to get the content from. So we'll define that origin. And within that origin, we'll need a domain name. So the domain name will be our bucket's domain name. So you can specify that like we did here with ID. Remember, our bucket within the Terraform configuration is called website underscore bucket. So I'm going to use that here. Dot bucket underscore regional underscore domain name. There you go. So that's going to be the domain name for our region. And then the origin ID is, so you can use the bucket ID here again, but you also have the ability to use the variable, because remember, whatever our variable is here, that will be the bucket name, so we can still use that. Just trying to explain two different concepts, how you can use values from previous resource or how you can use variable declarations. Now for the S3 origin, because this kind of tells us that we are using the S3 origin as the origin for our CloudFront distribution, we need to create an OAI, which stands for Origin Access Identity. And if you do this in the console itself, so if you go into AWS and do create an S3 bucket, create CloudFront distribution, and link that, like create a CloudFront distribution for your S3 bucket, you'll still have to do this, but through a wizard. So instead of doing that, you're just defining it, all of it within the Terraform configuration. So the origin access identity, we haven't created that, right? So we can't specify it here. So what I'm going to do is go up and create a origin access identity, which is pretty simple. It's not as complex as the other resources. So here I'm just creating a origin access identity, and I'm naming it origin access identity within the Terraform configuration, and I just have a comment within that resource. So here now we can specify that, and we'll be using the path of our origin access identity that was created over here. So I can do that by typing in origin access identity dot origin access identity and then dot CloudFront access identity path. So this is what we need right here. Okay. So we have the S3 origin configured here. This all comes under the origin block. Now, few other settings. So we do want to make sure that our CloudFront distribution is enabled. So you can set that to true. I also want to make sure that IPv6 is enabled. I can set that to true. And the default root object, which will be the index.html, I'm going to set that to var.website underscore index underscore document, just so that we have few variables, right? So for now, we only have one variable, but since I want to show you how you can, declare variables with Terraform, what I've done is created, or I've used another one. We haven't still declared this. So I'll be declaring another variable called website underscore index underscore document, and we'll assign it a value. The other few settings that you need is a default cache behavior. So this, we can kind of copy and paste it from the documentation. Again, you can read more about what caching mechanisms are available or what cache behaviors are available within CloudFront. Since we will be focusing more on Terraform, let's go ahead and copy and paste it. There we go. So what I'm doing is I'm allowing only get method, right? Even for cached, I have get and head, and then the target origin ID, we're using the bucket name. And within that default cache behavior, you can see there are other settings. There are some other settings too. So the one that I care about is the redirect to HTTPS. So what I'm going to do is copy and paste that too here. And you also have the ability to define the minimum time to live and the default time to live and maximum time to live for your cache. So let's go ahead and paste that. So here you can see that I have used the viewer protocol policy to redirect to HTTPS. So nobody can look at my CloudFront distribution over HTTP, which is, a good security feature. Now, if I hover over the red line, which is really distracting that I've found, is that we do have two settings left which are required. So we need restrictions and viewer certificate. So viewer certificate is, since we have mentioned HTTPS, you need to have a HTTPS certificate. So what I'm going to do is mention that here. So if I type in viewer certificate, and we'll use the CloudFront default certificate. So CloudFront default certificate, and set that to true, which means we'll be using CloudFront default certificate. And now we have to also define restrictions. So restrictions, a good example is geolocation restriction, right? So geo restriction, I don't want any restriction, but if your website, you might have some regulations or some compliance stuff if you're doing this for your work. So you can kind of define that here. So in my case, I have no issue with people accessing my website over the globe. And now we can also, this is not required, and that's why you can see we don't have any squiggly lines apart from the variables. But you can also define tags, which is a really good practice within AWS to make sure you're tagging your resources. So name can be name can be CloudFront distribution, and environment can be set to production. Let's set it to dev, since we are just developing this, but you get the idea. So that is our tags and the CloudFront distribution, along with the origin access identity. So we are almost done with this part 2. We already covered the S3 bucket. The only thing left now is for our bucket policy to be defined. So remember, we created the origin access identity. Until now, the CloudFront distribution will be created with this origin, but it won't have the access to the bucket because we never told this identity within our bucket policy to be accessed, or have that access. So what we'll do is create another resource now. So the resource we call is AWS _S3 _ bucket policy. There we go. And we'll name this our website bucket policy within the HCL or the Terraform configuration. There we go. And again, if you hover over it, you'll see that you need bucket and a policy. So for bucket, you already know that it's AWS S3 bucket, website bucket .id. And for policy, I'm gonna use JSON code. So you can encode JSON within your Terraform here. And you can do that by using this. So if you go to AWS CloudFront documentation on how to connect it to an S3 bucket using, origin access identity, you'll find this policy. So as you can see, the only thing that I've changed within this policy is the resource. So for resource, what I'm using is an S3 bucket, which we created, right? And it's ARN, which is the resource name. So ARN stands for Amazon Resource Name. So we are using the ARN for our S3 bucket here. That's the only thing I've changed after copying this policy from AWS documentation. But basically, you can see that the action is to get objects from S3. Effect is allow on this resource. And the principal that will have this policy is the origin access identity. So which we created over here. So get the idea. By using this JSON policy, we are giving our OAI access to get objects from S3. So now I'll save this. And we'll have some errors because of the variable names. So the best practice is to have variables.tf for any of the variables that you want to declare. which, I highly suggest you declare variables wherever you feel like it's necessary. So in our case, we had bucket name, we had the website index document, right? So let's go ahead and do variable. So just like resource, the keyword to define a variable is variable and the name. So in our case, the first variable was bucket underscore name. As you can kind of see right over here, now we don't have any squiggly lines, right? And now you can assign it a default value. So I won't suggest to give it a default value. You can also have, a type. So in this case, this will be a string, or if it was some kind of other variable, it would be integer, right? So you get the idea. And what else you can do is you can also provide a description. So if you're using this Terraform template within your team, if you run Terraform plan and apply, you can provide a description for this variable, which will output in the terminal if they haven't assigned this variable a value. So it'll say whatever this description is. So in our case, let's give this a description of this is the bucket name for S3. And you can provide it a default value, but if you don't pass it, it'll throw an error or will say, hey, please assign bucket name a value. So to keep things easy, which I don't suggest, you should not give it a default value, especially for a bucket name, but I'm going to randomly type in my bucket 7865A. Let's see if that gets created, because remember, you need to have globally unique bucket name. So that's our first variable. The second variable was website index document, I believe. There we go. So you can copy this and declare it here by typing in variable, paste that variable name, and give this a description. The description is, this is the website's index document. Again, this can have a default value because most of the time it's going to be index.html. So there we go. We have two variables within our main.tf. Both of them are declared in our variables.tf. That's where you declare your variables, and our Terraform code is looking good so far. The next thing that we have to do is also generate some kind of output. So once we run Terraform plan, and then we look at our plan and say, okay, we're good. Now let's Terraform apply. It'll provision the infrastructure, but I wanted to output the value of the CloudFront distribution or the domain name, right, which we'll be using to access our website. So you can do that by creating an outputs.tf. So there we go. We have our outputs, and you might be able to guess this. It's pretty easy to define output, just like we did with the resource or variable. Is you just say output. And let's go with the S3 bucket name, so that we have multiple outputs. No other reason, because we already know the S3 bucket name because we defined it in our variable. Okay, so that will give us our bucket. The main one that I'm looking for is the CloudFront distribution domain name. So the value of this, oops, I missed the bracket here, and then one here. There we go. So AWS CloudFront distribution dot domain name will give us access to the domain name. So I'm going to hit save, and I feel pretty confident that our resources will be launched. So let's go ahead and do that. And this is going to be the most exciting part. So before you do this, remember, I have Terraform CLI. So Terraform -- version. You can see I have version 1.7.3, which is out of date. So I should probably update it. But I also have AWS CLI and configured. So AWS CLI is able to authenticate to my AWS account. And this is how my Terraform will communicate with my AWS account, right? Because remember, Terraform still needs access to our AWS account to create these resources or infrastructure. So let me clear this and type in Terraform init, which initiates the Terraform project. So within our directory, you'll see there is .terraform that got created and a log file that was created. And with the init command, what it was able to do is also download the HashiCorp AWS provider, as you can see right here. So now let's run Terraform plan. Okay, so you can see the output here. I'm just gonna kind of minimize this. So if I go on the top, you can see the plus sign means create, and Terraform will perform the following actions. So we have a CloudFront distribution, right, with all of these settings. We have origin restrictions, certificate. We also have the AWS CloudFront origin access identity. We also have the bucket right here. We have a bucket policy. We also have the error.html and index.html. So the plan says there are 6 to add, 0 to change, and 0 to destroy. And then the outputs, these are the 2 outputs that'll give us. So 6 resources will be added to our AWS account. Now, you see how it has 0 to change and 0 to destroy? So this is where the state file that we talked about very briefly in the beginning. So state file is generated by Terraform itself when you run Terraform apply. And that basically remembers the state of your infrastructure. So in our case, we have 6 to add, but let's say this was deployed, right? So if we did Terraform plan again, it would say 0 to add because it'll look at the state and see that, hey, I've already deployed these 6 resources until and unless we changed something. So now if I do Terraform apply, you'll see that if you want to perform these actions, enter yes. So we'll say yes, which means we are approving these actions that are going to take place. You can see that I'll start creating the resources and it should take a few minutes. So I'll be back once it has done creating these resources.
A few moments later.
Okay, so I'm back and you can see the apply was completed. Resources 6 were added, 0 changed, 0 destroyed, and we have the following outputs. So it almost took 3 minutes and 20 seconds. And so this is our CloudFront distribution domain name, which is very suspicious because this looks funny. But let's go ahead and copy this, go to our browser here, and I'm going to close a few tabs here and paste my CloudFront distribution. And hey, we have a static website that's working. So if I hit refresh, you can also see the cool typing effect that I have. But yeah, it just takes to my socials and stuff. And let's go ahead and access the error.html. And you can see that there is an H1 saying, oops, there is an error. So great, our website is working over CloudFront utilizing S3 bucket. And that was our goal for this project. So now Remember, I was talking about the state file, right? So that state file is being stored locally. So let's say if you are a team of 8 engineers that are working on this Terraform code and deploying new resources, changing resources, or deleting them, you'll mess up the state file, right? So you need to have a backend configured. So if I go back to the output that I got running Terraform init, you'll see that if you ever set or change modules or backend configuration for Terraform, rerun this command to initialize your working directory. So here you can see backend configuration as a term that is mentioned. So what you can do is you can use Terraform Cloud, or you can use an S3 bucket to store your state files. That way, they're not being stored locally, and you have the ability to work within teams having the same state file. So the state file is necessary, and if you mess it up somehow, you'll probably have to reinitialize and restart your project. So that's an important tip. Make sure your state file is somewhere secure, but also in a place where other engineers can access it, and backend configuration is how you set it up. It is a bit in depth for this course, so comment down if you want me to cover some advanced topics within Terraform. But let me show you a quick example. So now that we have our Terraform infrastructure deployed to AWS, we saw that our website loads. Let me run Terraform destroy. What do you think it'll do? So you can see it has 0 to add, 0 to change, but 6 to destroy. How does it know that there are 6 resources to destroy? This is from the state file. So it is able to look at the state file and say, hey, I already have this deployed, which means when I do destroy, I need to destroy these 6. I'm going to enter yes, which is also a cool way to get rid of the resources that we deployed today for our project, so that you don't incur any charges, even though with S3 and CloudFront, it's very minimal, and it's the best way to host your static websites. But yeah, that is another concept of state file. And also, make sure you are using Git or any other kind of version control system to have your project, there. So upload it to GitHub or GitLab, whatever you use. In my case, all of this will be available on GitHub. I'll make sure that the repository is linked down in the description. But make sure you have added gitignore. So gitignore basically ignores the files that you don't want to commit to your public repository. So let's go gitignore Terraform. There we go. So make sure you copy this, go into your Terraform, create a new file, call this .gitignore, and paste that in here while our infrastructure is being destroyed. Save that. So this way, your state files are not committed to your public repository. So that was another tip for you. Now, before this can get destroyed, what I want to show you is also how to have different Terraform files. So usually the best practice is to have provider.tf, which will have this bit and any other providers that you might be using. So there are, as I said, GCP, Azure, multiple cloud providers, but also like self-hosted providers, and also some libraries that I've used, which are from a provider. So if you have multiple providers, it is best to use provider.tf and take it away from your main.tf, and also have like resource-based Terraform files. So let's say if we had S3 bucket and S3 objects, I would have s3.tf, and that would have these 3 resources along with the policy at the bottom. Same thing with the CloudFront would be to have cloudfront.tf, and that way it's compartmentalized into, it's easy for my teammates or other engineers to kind of make sense of the code. They know that S3.tf will have S3 resources and CloudFront.tf will have CloudFront resources. And similarly, since I didn't go over the custom domain part, if you had Route 53 resources, you'll have that in there. But yes, that is the way to go. Again, as I said, these are some advanced concepts. Make sure, I don't know how the demand of this course will work out, but if there are enough comments, I can go over and cover some advanced topics within Terraform. So nearly after 33 minutes and 45 seconds, we have our destroy complete. So our bucket, CloudFront distribution, all of those 6 resources that got created have been destroyed. So I don't have to worry about any charges or stuff or be paranoid about them. But yeah, let's go ahead and do that. Have a different file for provider.tf. And within our main.tf, we'll cut this out of it and save it here. So now you can see that in our provider.tf, we only have our providers. Hit save. Go back here, get rid of the white space. And there we go. So that looks way more cleaner. Even if you look at the directory structure. So I know my providers are in provider.tf, my variables are in variables.tf, and my main.tf is where all of my resources are, which is one of the best practices. So yeah, that was Terraform, which is a really popular infrastructure as code tool being used with AWS to create resources for a static website. And we deployed S3 bucket and CloudFront to our AWS account using Terraform. I hope you like this course. Again, I create all of this content for free. I would really appreciate it if you leave a like, leave a comment, and make sure you're subscribed so that you don't miss this type of content. Yeah, I hope you liked it, and I'll see you in the next one. Peace.